In this simulation, we will examine the reaction of metals with dilute acid. The reactions with dilute acid are also useful for distinguishing between the reactivity of some metals. Why isn't the reaction with dilute acid used with lithium, sodium, or potassium? There wouldn't be a reaction because of the oxide layer on the surface. The reaction would be so rapid it might cause an explosion, or because they only react with alkalis. The reactivity series shows that lithium, sodium, and potassium are highly reactive metals, and this means that the reaction with the acid will be a vigorous reaction. Because sodium, lithium, and potassium are reactive metals, the reaction would be so rapid that it might cause an explosion. Let's look at the reactions of some metals which are described as having medium reactivity. If a metal reacts with dilute acid, hydrogen gas will be produced. We can look at how quickly the bubbles of gas are given off to judge a metal's relative reactivity. Let's start with zinc. We will add dilute acid to zinc. Notice the bubbles of hydrogen gas. Let's examine now magnesium. The formation of hydrogen gas is less vigorous with magnesium. Which statement is true? Magnesium is more reactive than zinc, or zinc is more reactive than magnesium? The more reactive metal will react in a more vigorous reaction. Excellent. Magnesium is more reactive than zinc because the bubbles of gas are produced faster. Here is the equation for zinc reacting with dilute sulfuric acid. Zinc Zn plus sulfuric acid H2SO4 will produce zinc sulfate ZnSO4 plus hydrogen gas H2. Let's examine how lead reacts with dilute acid. As you can observe, lead do not react with dilute acid. No gas is produced. This is iron reacting with dilute acid. Iron can react with dilute acid and hydrogen gas bubbles are observed. And finally, we have tin. Tin reacts with the acid in a very slow reaction. Let's now arrange these metals, which are lead, iron, and tin, in order of reactivity. The most reactive metal is the one which reacted the fastest. So iron is the most reactive metal as we have observed a lot of hydrogen gas bubbles. Lead is the least reactive one, and tin lies between iron and lead. Lead and tin will give off hydrogen gas more quickly if we warm up the dilute acid. However, some other metals such as copper, silver, and gold will not react even in warm dilute acid. So this is the reactivity series showing the reactivity of metals. Platinum, gold, silver, and copper are metals of low reactivity. On the other hand, potassium, sodium, lithium, and calcium are metals of high reactivity. And here we have some other metals such as magnesium, aluminum, zinc, iron, tin, and lead. For example, from this reactivity series, we can conclude that calcium is a more reactive metal than aluminum. On the other hand, lead is a less reactive metal than zinc.